The blueprint of the abyss. Imagine you are an architect working for a massive, multi-billion-dollar construction firm called Evolution Incorporated. Your job is to design the perfect underwater survival machine. You experiment for millions of years, trying long, vulnerable tails, soft bellies, and even stolen snail shells. But every time you run the simulation, you end up at the exact same conclusion. The most efficient, durable, and successful design possible is a flat, armored disc with 10 legs and 2 massive, crushing claws. You have just discovered the crab. But here is the truly bizarre part. Evolution didn't just find this design once and stick with it. It found it, lost it, and then reinvented it at least 5 separate times in completely different families of creatures. In the world of biology, this phenomenon is so consistent that it has its own name: carcinization. The term was coined in 1916 by an English zoologist named L.A. Borradaile, who described it as nature's tireless attempt to reach the crab-like state. To a casual observer, a crab is just a crab. You see them at the beach or on a dinner plate and don't think twice. But if you look at the family tree, you discover something startling. Many of the animals we call crabs are complete imposters. They are false crabs that have spent millions of years performing a masterclass in cosmic cosplay. To understand why this is happening, we first have to define what a true crab actually is. In the world of marine biology, true crabs belong to a group called brachyura, which literally means short tail. Almost all decapod crustaceans, the group that includes shrimp, lobsters, and crabs, originally started with a shrimp-like body plan. This means a long, muscular abdomen, a shell that is longer than it is wide, and a prominent tail. For lobsters and shrimp, this tail is a powerful tool. They use it for the charadoid escape reaction, snapping their abdomen downward to rocket backward through the water like a living jet ski. It is fast and effective, but from a predator's perspective, that long, meaty tail is essentially a giant grab-here handle. It is a massive vulnerability. To become a crab, evolution performs a radical surgery known as brachyurization. It takes that long, dangerous tail, shrinks it down until it is almost invisible, and then folds it tightly underneath the body. The upper shell, or carapace, becomes wider and flatter, and the legs move to the sides, allowing for that iconic side scuttle. The center of gravity lowers, and the vulnerable internal organs are tucked away behind a solid wall of thick calcium carbonate. This body plan is the Swiss Army knife of the ocean. It is perfect for burrowing into the sand, climbing through jagged coral reefs, or sprinting across the deep sea floor. It is so successful that nature seems absolutely obsessed with it. The most famous example of this evolutionary impersonation is the king crab. If you go to a high-end seafood restaurant, the king crab is the prize. It looks, acts, and tastes like a crab. But biologically, a king crab is not a crab at all. It is a member of the Anomura group, a massive family of false crabs that includes hermit crabs and squat lobsters. The king crab's closest living relative isn't the blue crab, it is the hermit crab. Millions of years ago, the ancestors of king crabs lived inside stolen snail shells to stay safe. But as they grew larger, the search for a bigger house became exhausting. Eventually, natural selection favored those that could strengthen and calcify their own abdomen, effectively growing their own shell. They flattened their bodies, tucked their tails, which still remain slightly asymmetric as an evolutionary scar of their shell-dwelling past, and evolved into a form almost indistinguishable from a true crab. You can actually spot these imposters in the wild if you know the secret. True crabs have 1 pair of claws and 4 pairs of walking legs. But many carcinized anomurans, like the king crab or the porcelain crab, only appear to have 3 pairs of walking legs. Their 4th pair has shrunken down and is hidden under the shell, where it is used mainly for cleaning their gills.
This suggests that evolution isn't a purely random walk through time. The crab paradox suggests that the tape of life has tracks. There are certain biological shapes that are so mathematically superior that they are inevitable. In a way, the crab is a biological attractor, a point in the landscape of possibility where life keeps getting stuck because it has found perfection. But why the crab? Why is walking sideways actually an engineering masterpiece? And why did some true crabs try to give up their claws and go back to being lobsters?
To find out, we have to look at the hidden physics of the crab joints and the mysterious rebels who decided that being a crab was actually a trap. The sideways masterpiece and the rebels. To understand why evolution is so obsessed with the crab, we have to talk about the one thing everyone makes fun of, the sideways walk. To us, it looks clumsy, but in the high-stakes engineering of the ocean floor, it is a stroke of genius. Think about the physics involved. Most animals are built for forward movement with a narrow front and a long tail, which is excellent for swimming in a straight line, but terrible for stability and maneuverability in tight, rocky spaces. A crab's body is a wide, flat platform that allows for an incredibly low center of gravity. This makes a crab almost impossible to tip over, providing exceptional stability on the uneven, jagged terrain of the seabed. Furthermore, by moving sideways, their legs do not trip over each other, allowing them to navigate narrow, rocky crevices with surprising speed. They can change direction instantly to evade a predator, while most of their enemies can only attack primarily in a forward direction. This sideways solution is so effective that modern robotics researchers are literally building search and rescue machines modeled on crab joints. They have realized that if you want a machine that can navigate unstable, jagged ground without falling over, you don't build a human model, you build a crab. But if the crab form is the pinnacle of design, why doesn't every single creature have claws and a flattened shell? This brings us to the rebels of the crustacean world, the phenomenon of decarcinization. Evolution, as it turns out, is not a one-way street. Just as some land animals returned to the sea to become whales, some crabs decided that being a crab was actually holding them back. The best example is the family Rhininidae, commonly known as frog crabs. These are true crabs from the brachyura group whose ancestors went through the full crab protocol millions of years ago. However, as their environment changed to areas with loose, deep sand, being a wide, flat disc became a nightmare for burrowing. It is like trying to push a dinner plate through a bag of rice. To survive, they reversed the process. Their bodies became long and cylindrical again, and their tucked-under tails started to re-emerge to help them dig. They are literally uncrabbing themselves to survive in a specific niche. Researchers have identified at least 7 independent cases where nature looked at a perfect crab and decided to give the tail back because the environment demanded it. This tells us that carcinization is not an inevitable end state. It is a specialized tool. It is part of a much larger concept called convergent evolution. This is the idea that nature has a limited catalog of successful solutions for specific physical problems. If you want to be a fast predator in the open ocean, physics will eventually demand that you look like a torpedo, whether you started as a fish like a shark, a reptile like an ichthyosaur, or a mammal like a dolphin. If you want to be a small armored scavenger on the ocean floor, the laws of fluid dynamics and gravity will eventually demand that you look like a crab. The most explosive evidence of this universal blueprint happened during the Cretaceous crab revolution, between 145 and 66 million years ago. This was a smaller part of the Mesozoic marine revolution, a massive global arms race in the prehistoric oceans. Marine predators were developing more powerful jaws and specialized tools for crushing and drilling into shells. In response, potential prey had to adapt or die. For many crustaceans, the most successful strategy was to ditch the long, meaty tail, which predators could easily grab, and invest in a compact, armored tank-like body. During this period, nearly 80% of modern crab groups originated, experimenting with forms that were as bizarre as they were effective. One of the strangest results was Calicamera perplexa, the platypus of the crab world. This 95-million-year-old creature combined a crab-like body with massive, unprotected compound eyes and paddle-like legs for swimming. It was an active visual predator that refused to crawl on the bottom like a standard crab, choosing instead to hunt in the open water. The crab shape is the Swiss Army knife of the natural world. It works for the tiny pea crab, which is less than a centimeter long and lives inside oysters. It works for the Japanese spider crab, which can have a leg span of nearly 12 feet, looking more like a piece of deep-sea furniture than an animal. It even works for the ghost crab, which can sprint across the beach at speeds of over 2 meters per second, using a biological motor that functions much like the muscles of a mammal.
Nature is a cosmic sculptor that keeps returning to the same few statues because they are the only ones that don't fall apart under pressure. But there is one creature that takes this cosmic blueprint to a level that borders on pure horror. A giant that proved that once you become a crab, you can even leave the ocean behind and become an apex predator of the land. The terrestrial titan and the cosmic crab. We have seen how evolution relentlessly pulls life toward the crab shape in the deepest ocean trenches and the shallowest coral reefs. But what happens when the crab decides that the entire ocean is no longer enough? This brings us to the final, most terrifying boss of the carcinization phenomenon, the coconut crab, Birgus latro. If you were to encounter a coconut crab in the dark of a tropical night, your first instinct would be to run. These creatures are the largest land-living arthropods on the planet, boasting a leg span of over 3 feet and weighing up to 9 pounds. But here is the evolutionary secret. Just like the king crab, the coconut crab is a master of cosmic cosplay. Biologically, it is a giant relative of the hermit crab that took the crab protocol to its most extreme conclusion. In their youth, coconut crabs behave like typical hermit crabs, scrounging for empty snail shells to protect their soft bodies. But as they grow, they undergo a radical transformation. They stop searching for a house and they become the house. They develop a massive, calcified carapace that is so strong they no longer need to hide. Their evolution didn't stop at armor. To survive on land, they developed branchiostegal lungs, specialized tissue that allows them to breathe air. They have become so adapted to the land that an adult coconut crab will actually drown if submerged in the ocean for too long. But the real horror lies in their strength. In 2016, researchers measured the crushing force of their claws, and the results were staggering. A large coconut crab can exert a force of 3,300 newtons. To put that in perspective, that is roughly 8 times stronger than the grip of a human hand and rivals the bite of a lion. They use this power to rip open solid coconuts, but they are also active predators. In 2017, biologist Mark Ladry documented a scene out of a horror movie. A coconut crab climbing a tree to attack a sleeping seabird, a red-footed booby. With one swift motion, it snapped the bird's wing, dragged it to the ground, and was joined by 5 other crabs for a collective feast. These false crabs have created a landscape of fear, effectively pushing ground-nesting birds off entire islands. So, how does nature keep repeating this complex design? The secret lies in the Hox genes, the master architects of the animal kingdom. These ancient genes determine the body plan of almost every animal, from flies to humans. Researchers studying the Chinese mitten crab discovered that during the transition from a larva to a crab, the activity of specific Hox genes, such as SCR and ANTP, is significantly reduced. This genetic switch triggers brachyurization, causing the tail to shrink and tuck under the body. This suggests that the crab blueprint is already pre-programmed into the DNA of many crustaceans, waiting for the right environmental pressure to flip the switch. This raises a final cosmic question. What does carcinization mean for life beyond Earth? If the laws of physics, gravity, fluid dynamics, and structural engineering are universal, then the problems of survival are the same everywhere. Astrobiologists suggest that on any planet with a rocky floor and a liquid ocean, the flat, armored, 10-legged design might be the only mathematical solution for a scavenger. The crab isn't just an earthly quirk. It is a biological attractor, a point in the landscape of possibility where evolution stops experimenting because it has found perfection. We joke about returning to crab, but the reality is even stranger. Life on Earth has already made its choice. The blueprint is set, the armor is grown, and the claws are ready. In the grand simulation of existence, we might think we are the protagonists, but while we build cities in the depths of the ocean, nature is busy perfecting the machine. It is waiting for the next creature to realize that the only way forward is sideways. Everything returns to crab. Eventually.